Uh, Hi, good afternoon, everyone. Thank you for joining us here in this afternoon session after some technical difficulties with transmitting large files. Okay, wonderful. So I'm here to talk about the applications on top of which we're building smart cities of tomorrow on top of wireless foundations in particular. But most of the focus of the next few slides is just how we're envisioning future streetscape applications to look. And so, you know, this is part of the broader Center for Smart Streetscapes, which is part of Engineering Research Center funded by the National Science Foundation. And of course, the objective that we're focused on is really in creating streetscape applications of tomorrow. One of the biggest applications these days that's emerging is improving pedestrian safety. And so what we're seeing is there's been a massive increase in the number of pedestrian fatalities in streets throughout America. We've seen a 75% increase, in fact, since 2010. And if you dig into this demographic a little bit, you can see that that the largest portion of that demographic is age 50 to 64. But you know, the 20 to 49 is not that far behind, and in fact, it doesn't get any better as you get older. We think that this is, you know, obviously a massive problem to go after in terms of being able to increase visibility and situational awareness on the street. One of the core challenges here is that streets are getting more complicated. There's more vehicles, there's more electric vehicles, there's just a mixture of different types of mobility in the street, and they're essentially getting past the point at which they were designed. We think one aspect of this is a mobility impairment problem. Mobility impairment meaning, you know, broadly speaking, folks with children, people who may be blind or disabled in some way, and that there's just a general lack of situational awareness by all the people who are on the street, not just the pedestrians who are walking, but also the people who are driving these vehicles. And so in order to sort of broadly open up the street as a place to test for these safety applications, we've proposed a streetscape application services stack where the primary objective is to make multimodal a first-class primitive. And so that means that we have to be able to take different kinds of sensing equipment, different sensors, put them together in smart ways to improve, again, situational awareness on the street. And we have to do this on top of a high-speed wireless infrastructure because naturally, if it's going to be a highly interactive system, you certainly need that to be a tight, closed loop. And so the kinds of applications that we're envisioning supporting are applications such as the adaptive street lights or pedestrian traffic tracking and interaction. So here's a first look at the application services stack, and you know we'll sort of dig into different slices of this picture. At the top, we have the software layer, and of course, most of the stack actually sits up in the software layer. So we're considering things like, you know, caching in order to get for fast lookups, different types of APIs that are aggregating the information and making this information available in real time, and the various applications that sit on top to exchange information about the sensing streams that are being captured from the street. At the bottom, of course, is really, this is where the wireless foundations fit in that we have an edge cloud environment where we're considering computation and communication that's attaining the information and forwarding it where it needs to go. And one of the core challenges, of course, is considering what the application constraints are in the context of this very dynamic environment to meet real-time demands. On the left side, we have the storage providers. Again, they mostly live on the software side. So this is things like managing the data as it comes in, managing its lifetime. On the server side, this is where we link the hardware and software layer to make the data available and to do scheduling. And the application layer, this is where we run the applications, right? And this is also where we mediate access to the sensors and actuators that are on the street. And as I mentioned before, the bottom layer, this is where we're doing all the edge cloud work where we foresee doing the edge cloud work for considering all the real-time optimizations that we have to do to enable these applications. So here's an example of this is supposed to be animated. Unfortunately, it's not fully animated here, but we are doing real-time tracking of pedestrians out in the street. And in fact, because we want to enable interactive applications, it's not always the case that a person can proactively engage with the street itself. In fact, the street needs to initiate contact with the individual to provide warnings or to have targeted messaging. And so what you're seeing here, and partially seeing here, is a stream of IMU data coming in and a multi-view perspective of the pedestrians as they're walking. And we're matching the stream to the pedestrian. Here's another more end-to-end application, which is a video. Hopefully it will play. Let's see if I can. I know. It's rendering a little different from the actual app, that's why. Yeah. Maybe if I click on it, nope. They're both two videos. Oh, it seems like it's loading, so that's good. Try to full screen it here. It's hard. Yeah, it is, yeah. Okay. Oh, there it is. Great. So the localization is being performed by the Streetscape itself, with this data streaming in and identifying who has gestured for the extra help. Okay, so that's one example. And so this is actually just a short view of the full application, which actually entails providing step-by-step navigation to a blind pedestrian. Some other features of this application are the ability to determine what the countdown is as they're crossing the street to figure out how much time they have, and dictate those real-time constraints in terms of getting that level of interactivity, but also track the obstacles around them in 2D so that you can infer where they are precisely and see if there's any oncoming collisions. In another application, we're also considering doing more hyper local, if you will, information. So from a first-person perspective. So let's give this one. So what this application does is it takes sensor data it's trying to infer the distance from you to the obstacles around you, and also provide a level of description of the scene, because we've heard in prior studies, folks who are blind have heard that just having a general sense for what is in their surrounding, even if it's not an immediate threat, is useful for them to picture as they're walking through the street. So these are the kinds of applications that we're really envisioning. This is just a small slice of some of the apps that we're building onto this smart streetscape. And again, one of the core questions is how to integrate everything from the application down to the wireless foundation, down to the edge cloud foundation. And so in this evolving stack for smart cities, we're making it real-time, wireless, and edge-ready. Where another aspect of the stack that we didn't get to go into is, of course, privacy. That is a first-class concern as well, and the fact that we have to have a way of providing multimodal services for putting together all of this information within the context of being able to provide the services that we're promising. So there was an interesting question about how you reason about that from an information perspective, and when to drop certain sensor feeds. And I think that's still an open question that we're also exploring in the context of this application stack. Okay, and with that, I will take questions.
Any questions?
I might didn't notice in the presentation, but did you say what sensors you used to say who is next to you, left to you?
Right now we're doing, we have mostly cameras out there. There's been a push now to use the cameras to train models off of non-camera based sensors. So doing cross-modal inference and building cross-modal inference models for that. For the Vision Assist project, they had like a small LiDAR device that was attached to the phone itself, but we weren't using infrastructure sensors for that. So we're planning on taking that application, which is just run locally, and actually do it out in the street with the sensors that are in the street.
Are there some estimates on how much data this type of environment and these applications would be driving at the edge there?
Exact numbers I don't have, but we are opening it up to multiple camera feeds, high definition, LiDAR, the wireless data that we may get. Of course, there's a ton of data there, and it's the infrastructure that will have to mediate what data is passed to which applications and how to do that efficiently. I think some of the open questions for the applications, particularly on the bottom, is figuring out when you're going to move the compute to the data versus move the data through the compute, right? And so this is an interesting question, because there's a fundamental tension between privacy and the data that these applications might need. And so you want to add more compute in order to provide higher levels of privacy, but you may lose utility in that trade-off space. And so it's something we're exploring.
But having the compute at the edge is always better from that perspective, I guess?
I think in many cases it is, especially if you can't guarantee real time otherwise, right? Then you have to move the compute closer to the data.
Right, right.
Yeah, just one question about the data format, because these are different types of data. Therefore, and this should be shared among different types of applications. So are you using a specific data format? Otherwise, it will be difficult to exchange this data.
I don't understand what data you're referring to. I can't understand what.
All the data that you basically get from all these sensors must be fed to specific, let's say, applications.
Correct.
Exchange.
Right now we have a pub subsystem to decouple the two.
Yeah, but the kind of data that you transport, the structure of the data, do you use your proprietary format, or you rely on specific standards?
We don't. We're sorry, I don't understand everything you're saying, maybe because it's muffled, but we are built. I guess I don't know how to answer the question. We have streams of data that are going to a server, and we have a subscriber, a pub subsystem that's forwarding that data to the applications that
is correct. That is correct. However, the data, the fields of the data.
Oh, the feeds. You're saying feeds.
Yeah.
Sorry, I didn't understand that. Yeah, it's a actually RTSP. Yeah.
Okay.
But it's actually real time, and you will hear it. You will hear it later. Real time is a problem we are trying to
Yes, thank you. So you mentioned multimodal sensoring. Like, what kind of type of sensors you are considering, and also, do you assume this would be a part of the future kind of infrastructure in the city?
We do. To answer the second question first, yes, and that's what we're hoping. In terms of multimodality, in the current instance, we've considered two different types of sensors, but different types of modalities. So a modality is a distillate of a different modality can be considered a distillate of the raw data. So just by transforming the data into a different view, you have a different modality. So in that sense, multi-view is considered multimodal. As far as strict sensing-based multimodal, we've done cross-modal inference from IMU to vision data. And so we are observing streaming IMU data and matching the movement patterns in the IMU data with the movement patterns observed in the visual domain.
Okay, great. Thank you so much. Great discussion.
Thank you.